Hello again, ladies and gentlemen. Today we'll talk about descriptive statistics. Let's start by defining descriptive statistics. They are mathematical procedures that we can use to describe, organize, and summarize the most important general characteristics of a set of data. And of course, if you remember, calculating statistics is a very important step in test piloting and post-test analysis. After every test administration, we must calculate descriptive statistics. Now, what is the use of descriptive statistics? We know that we have to calculate them, but what are they good for? First of all, they allow us to interpret our numerical data and then be able to draw generalizations about test takers' performance. For example, we can answer questions such as the following. Number 1, is the level of ability of a given test taker better or worse than the rest of the group? And if so, to what extent? Secondly, is the level of ability of a given group rather homogeneous or heterogeneous? And then again, to what extent? The third question that we can answer with descriptive statistic is the following. Is the level of ability of a given group better or worse than that of another group? So we can draw comparisons between individuals and between groups of test takers. I will now proceed to the explanation of descriptive statistics, but I want to illustrate my explanations with one example. This is a picture of Napoleon Bonaparte, a great military leader and emperor. Very famous character in history. Whether you love him, whether you hate him, everybody knows him. Now, why did I choose Napoleon for this explanation? I chose him because there is the belief among people that Napoleon was a very short person. So the question that is going to guide our explanations is this. Was Napoleon tall or short? Was he very tall or was he very short? First thing that comes to mind is obviously that we cannot answer this question in an absolute sense. We obviously need to refer to other people, standards, and parameters, and that's precisely what descriptive statistics are for. So the first concept that we need to know is the concept of population and the concept of sample. Population is the whole group of people that we're referring to, and a sample is a small group of that population that we're going to use in order to draw generalizations about the general population. So in this case, given that Napoleon was a statesman, a leader of his country, we're going to compare him to other world leaders such as Barack Obama, Mariano Rajoy, Alfredo Rubalcaba, Nicolas Sarkozy, and Silvio Berlusconi. And we're going to see, we have the different heights here, but we're going to analyze this sample of group leaders, and then we will draw generalizations about whether or not Napoleon was short or not. So, just from the outset, we need to recognize that sometimes groups of people, or populations, or samples can be heterogeneous. In other words, that they have very different characteristics, such as the people that I'm showing you in this picture. On the other hand, some other groups or some other samples are going to be rather homogeneous. In other words, there will not be salient differences between the individuals in these groups. Okay, let's now start talking about descriptive statistics, and we will begin by the measures of central tendency. These are the statistics that tell you to what extent your sample has things in common. In other words, they summarize the performance of your sample population as a whole. And the most common measures of central tendency that we're going to be using in this presentation are the mean, the mode, and the median. The mean can be defined as the arithmetic average of all scores in a dataset. It is the sum of all the scores divided by the number of test takers. And this is the mathematical formula here. This is the symbol of the mean, and it's the result of the sum of all of the different scores divided by the number of people in your sample. The mean provides you with some global information about the characteristics or the performance of the group as a whole. I think of the mean as, putting all of the people in a blender and then mixing it up, and then you're going to have something that is the result of the combination of all of the people. This is what the average does. It provides you global information about the characteristics of the whole group. Now let's calculate the mean in our sample to answer the question concerning whether Napoleon was tall or short. So this is the formula, and then of course we can see that the mean is going to be the sum of all of the different heights, 168, 185, 180, 163, and so on and so forth. And we're going to divide it, of course, by the number of people. There are 6 people in our sample, and the result of this is 1.71. So Napoleon is 1.68, and we can see that he's only 3 centimeters below the mean. So from this first approach, we can say that Napoleon was not very short. He was very close to the mean height in the sample that we are studying here. A second measure of central tendency is the mode, and this is very simple because it's actually the most frequently obtained score in your dataset. So the mode tells you what is the performance that was more typical in your group. In other words, what is the number that appears more time. It can be a test score, it can be, in this case, like the heights of the people, and so on. So if your mode is high, chances are that the group as a whole had a high level of performance. And on the other hand, if your mode is low, chances are that the group as a whole had a low level of performance. That means if your mode is 10, it means that a lot of people got 10. If your mode is 5, it means that a lot of people failed the test, and this could be bad news. To determine the mode in our sample, the only thing that I have to do is to list all of the heights and then see which of them appears more often. In this case, it is 1.65. 2 people measure 1.65 meters. So in this case, we can see that Napoleon is 1.68, and so he's taller than the mode of the group. Let's now look at the median. The median is the score that appears at the center of the distribution when your scores are arranged from the highest to the lowest, and so it cuts your sample population in half. In the top half, you have the high achievers, that means the people who did great on the test. On the lower half, you have the low achievers, or the people who got bad scores on your test. So the median allows you to see whether the scores below the median are rather high or low, which gives you a precise indication of whether this taker's performance in the group was good or bad in general terms. Let's turn now to our data. What is the median in our sample? We have first 185, Barack Obama, then 180, then 168, Napoleon, right? Then 165, then 165, and then 163. So if you see, when we cut our scores in half, the half top in this case will be the tallest people, and the lower half will be the shortest people. So if you see, in this case, we don't have one score or one number, but we have 2 numbers. So in this case, what we're going to do is we're going to calculate by dividing this. Okay, so the median will be 1.68 plus 1.65 divided by 2. So our median in this case is 1.66. Okay, and then again, as you can see, Napoleon is taller than the median. So in this case, we could not say that Napoleon is short, at least for the sample that we're analyzing. The second group of descriptive statistics are the measures of variability. And basically, these ones tell you to what extent your sample populations differs, as the measures of variability show you the level of heterogeneity in your sample, they can indicate whether or not you can trust your measures of central tendency. So they will tell you to what extent the mean is reliable or not. The measures of variability that we're going to be looking at are the range and the standard deviation. There are some others, but we'll be looking at these two for the purposes of this lesson and this course. The first measure of variability is the range, and it can be defined as the value of the subtraction of the highest score minus the lowest score. You can see the formula there. So the range tells you how much variation there is in your sample. In other words, the difference between the highest performance and the lowest performance. And so, by definition, the larger the range is going to be, the more variation there is going to be in your sample. Let's see what happens to our group of word leaders. So in our sample, we have that the highest person measures 1.85 and the shortest person measures 1.63. So the range is 0.22, which equals 22 centimeters. And of course, 22 centimeters in human height is a great difference. And we can therefore conclude that there is a great deal of variation in our sample. In other words, the very tall people and very short people. The second measure of variability is the standard deviation. Now the standard deviation can be defined as the square root of the average squared deviation from the mean. In other words, the standard deviation is the average distance of individual scores from the mean. This is the formula. And what is important to mention about the standard deviation is that it provides the measure of how every individual score deviates from the mean, and it is thus too high or too low. Let's see what this means in our sample. We have the formula, okay? So the first thing that we need to do is to list all of the scores. The scores mean X from the highest to the lowest. Then we will subtract the mean of every individual score. That's X with the line on top. And then we're going to square all of these results, okay? Let's do the first part together. Here we go. So these are the individual scores here. We have them here, okay, from the highest to the lowest. Then we have the subtraction of the individual scores minus the mean, and on the last column we have the result of squaring this subtraction. So something important that I need to mention is that if you see, we have some negative numbers here, but when we're going to square these numbers, they become positive again. Remember that if we multiply a positive number, it is positive. If we multiply two negative numbers, they become positive. So when we square these numbers, they become positive again, and that's what we're going to see on the last column. The last column is actually the result of subtracting the mean from the individual scores and then squaring this result. Okay, so we have already solved half of the formula. This is the part that we have done. X minus the mean squared. Okay, and so we need to take the next step, which is to add all of these values. This little symbol here that looks like a capital E is the symbol, the mathematical symbol that means addition. So we have to add all of those little numbers that we obtained in the previous part and then divide them by n minus 1. So we have here all of the little numbers, and the result is 0.0439. So this number represents the addition of x minus the mean squared. Now the last part of the formula is dividing this little number by n minus 1. N refers to the sample, to the number of people in our sample. In this case there were 6 people, but the formula says n minus 1. So n minus 1 is 5. and the result of this division is 0.00878. This is the result of dividing the result by n minus 1. Now the only thing that is left to do is to calculate the last part, which is to extract the square root. I know that you're not very good mathematicians. I am not a very good mathematician, so for this operation you can use a calculator. So we're going to calculate then the square root of 0.00878, and the result is 0.0937. This is the standard deviation in our sample. Now, this result, 0.09, represents in our sample 9 centimeters. So the standard deviation is 9 centimeters. The average distance that there is between every individual score and the mean is 9 centimeters. Now let's see what the standard deviation represents in our sample. We said that it was 0.09 meters, in other words 9 centimeters. So we have here 1.79, which is the mean, okay? The mean is 1.71. So then we have one standard deviation on top, it's 180. So people who are taller than one standard deviation, who are after 180, are going to be considered tall. And then if we take 2 standard deviations to the top, that makes 1.89. So people who are 2 standard deviations from the mean are going to be considered very tall. On the other hand, if we go to the bottom part, we have minus 1 standard deviation is 1.62 centimeters. So people below 1.62 are going to be considered short. And in the same way, if we take 2 standard deviations below the mean, we're going to have 1.53. So people who measure less than 1.53 are going to be considered very short in this sample. So as we can see, just below 1 standard deviation or above 1 standard deviation, this is considered in our sample as regular or medium height. After 1 standard deviation, you become tall. 2 standard deviations, you become very tall. 1 standard deviation below the mean, that's short. 2 standard deviations below the mean, that's very short. So that's what the standard deviation does. And if you see in our sample, we said Napoleon measures 1.68. So in this case, he's not even 1 standard deviation below the mean. So we consider that in this sample, Napoleon is not short, he is medium height. So just summarizing the things that we did here, we calculated the descriptive statistics to see how this group of word leaders may be considered short or tall or very tall or very short. So in this case, the size of our sample was 6 people. The mean height is 1.71 meters. The mode was 1.65 meters. The median was 1.66 meters. And the range was 22 centimeters. Finally, the standard deviation was 0.09. That means 9 centimeters. So, summarizing, Napoleon is just 3 centimeters shorter than the mean, but he's taller than both the mode, plus 3 centimeters, and the median, plus 2 centimeters. We can also see that the group that we have analyzed is heterogeneous, with very short and very tall people. Napoleon is not even 1 standard deviation below the mean. So, again, at least in this sample that we analyzed, Napoleon is not short. He's actually medium height. So, this is the basic set of descriptive statistics. And the only thing that I have left to say is that in the same way that we drew generalizations about Napoleon's height, based on the statistical analysis of a sample of world leaders, we can do the same thing about any set of data. In other words, we can determine if a person's or group's level of ability is high or low. And for this purpose, we may perform a statistical analysis of other people or other groups, and we may compare them to some other parameters that were previously established. So that's basically what we do with descriptive statistics, and this is a very important step in test piloting and in post-test results.